Hi everybody, my name is Siraj Williams. I'm an energy consultant based in Cape Town, South Africa.
My name is Aníbal de Almeida. I am a professor at the University of Coimbra in Portugal. So basically, an electric motor is used in industry to convert electric power into mechanical power. Mechanical power is used to drive a huge variety of equipment: pumps, fans, compressors, conveyors, mills, all sorts of different types of equipment. So the motor is part of this motor system.
When we consider our industries in general, what we find, through scientific study is that almost 70% of all electrical energy consumption is consumed by an electrical motor. It follows then that if we want to optimize our energy consumption, motors or motor systems, more correctly, should be part of that assessment, or part of that study.
So if you are using a very good motor, very good controls, and the pump is not of high quality, it's like in an orchestra. You have 20 good musicians, but one of very poor quality, then the result is not good. The components in a motor system must be well selected, well sized, and they all must perform with high efficiencies. There is no room for poor performance in a motor system, because you can ruin the performance of the system just with one weak component, like the pump I mentioned to you. In the old days, most motors were connected directly to the main supply, and they worked basically at constant speed during all the time. What really makes sense is to control the speed of the motor as a function of the needs of the process. By doing this, you can save a huge amount of electricity, you can reduce the wear, you can reduce noise. So motor controls are, I would say, one of the key opportunities for energy efficiency in motor system.
I remember working at a petrochemical company, and they were using cooling water which was coming from a canal, approximately a kilometer away. After discussion with the cooling plant personnel, they said that our requirement is to pump 2,100 cubic meters of water per hour to the plant. On further discussion with the process engineers, they said, well, we only require 700 cubic meters of water per hour, and that's what we're actually getting. There were 3 pumps that were pumping, and we could switch one of those pumps off. And that was an immediate saving of about, 1/3 of the electricity. Because it was an eye-opener for the team. Not only the engineering management, but, the energy team as well. And they realized the benefit of actually sitting down and discussing systems, with an integrated approach. So this is really, the heart of what we're trying to do with the UNIDO, systems approach. So we need to be at the forefront of optimization all the time. It's a continuous approach. If we think about, the 100-meter sprint, it's not good enough just, to equal the record. We always want to improve on it. We want to improve the world record. And this is the approach, or the type of thinking, that we should have in our industries as well.